Today we are going to solve the problem trapping rainwater, which is the leetcode problem number 42. Although this is a hard level of question, we can derive the idea from the question we have already solved, that is the container with most water. First of all, let's understand the problem statement, what it is saying. Just like the container with most water, here also it is giving an array of height, and the height is going to be a height of the bars, and each bar width is 1 unit. Now we have to calculate how much water it will trap. This is the map for this height. As you can see, the 0th index having 0 height, the first index is having 1 height, the second index also having the 0 height, like this. Now when it will rain, then we will see where the water is going to trap. First of all, now here it's empty space, so in the first index it will not store any rain. In the second index, when it will rain, it will come out from the first index also. That's why here also it will not store any rain. Now in the third index it is 0, and when it will rain, you can see here, because of this bar and this bar, the rain will trap this much. And for this one also it will spoil out to the left and right, it will not store any rain. For this one, you can see up to here it can store the water, and for this index up to here, for this index up to here, and for this index up to here. Now we have to calculate how much unit it will store. You can see here 1 unit. 1 unit, why? Because of the height. 1 unit, 1 plus this index 1 unit, 1. For this index 2 unit, this one 1 unit, this one 1 unit, 2. Now here 1 unit, 1. Here it will not trap any water, here it will not trap, here only it will trap some water, which is 1. Now the total number of unit of water it is going to store as 1, 1, 2, 2, 2, 4, 5 and 6. Total 6 unit of water it is going to store. Now we will understand what create water means, when the water is getting trapped, with a small example. Now in this small array we can see how much total water it can store. We have seen in the container with most water, we always used to take the smaller height, because the water level only come up to the smaller height, because after that it will spoil the water. So the first thing is going to the level of height will be the minimum between left and right bars, and here it will trap this much unit, right? This is 1, 2, 3, 4 unit it will trapped. Now we'll understand one more thing with this particular map. Right now the first index is height of 3, second index is height of 1, and the third index is height of 2. This bar is not going to store any water, we already know this. For this bar, we have seen from this one, first of all we have to find out the minimum between the left and right. Okay, and when we got the left and right, the level of the water will be 2, right? But how much unit it is storing? 1 unit. Why 1 unit means, you can see here wall is there, you have to reduce this amount of unit, because here water is not going to store. To find out the trapped water for a particular bar will be, first of all we will find out the minimum between the left and right, and we will subtract with the height of current bar. Okay, so here it will be the minimum height is 2 minus how much unit wall is having 1, so the total number of water will store 1 unit. And one more thing you have to consider here. The left right does not means the next left and right. Suppose here our bar is there. Okay. We have to find out the maximum left and maximum right left and maximum right. From them we are going to compare to taking the minimum number of value. So we have to take the rightmost and the leftmost maximum. Then we are going to find out the minimum between that two and we are going to subtract the unit. So our formula will become like this. Water for each bar will be minimum between the max left and max right. The maximum height in the left side, maximum height in the right side for the particular bar minus the current height of the bar. We have derived this formula to solve this question right now. When we will try run this, you can get to understand more. First of all, let's think how a beginner will solve with this brute force approach. Suppose this is our array of height. Now, what we can do, for each element we have already discussed, we have to find the maximum left and maximum right value, right? So for each element, suppose for this element, we have to find the left max and right max, and we have to find out the minimum between two. Then we will subtract with the current height 4. Suppose for this element, what is the maximum value? 5 is the maximum and the left one 4. So 4 and 5. We have to find the minimum. What is the minimum? 4 here, and the height of the current element is 2. 4 minus 2 equal to 2. So this index we can store 2 unit of water. But for each element we have to find the rightmost maximum and the left maximum. That's why finding the maximum on both sides of every element, it can cause big O of n square time complexity. Now let's think about the two pointer approach. We know for each bar we have to find out the maximum left and maximum right bars. And whenever we are moving inward, again we are finding the maximum left and maximum right. Instead of repeatedly searching for this value, what if we maintain them while moving inwards? Suppose this is our array. We will start placing the left pointer and the right pointer at the both end in the array. Initially we will keep left max as 0 and right max as 0. Now which pointer we should move? Just try to remind that question we have solved, container with most water. Whenever we are searching for a container, always we used to move the smaller one, because the smaller one is determining the boundary, how much of water it will store. The smaller one always decided that. So whenever the left max is less than or equal to right max, we can safely move the left pointer. And whenever the opposite, like the right is less than left, we will process with the right pointer. Imagine that we have a left maximum of 5 and a right maximum of 10. Okay, and the current height is 2. Then how we are determining the water? 5, 10 minimum, this one left and right, minus height 2. Okay, so it is coming as 3. Now when it's time to move the pointer, we already having the left maximum as 5, smaller than the right maximum. Okay, we are already having a maximum value of in the left side, but which is smaller than the right one. So we can safely process the left one. If we got smaller value, still the maximum will be 5, and if we get a bigger value, then we'll change this left maximum. Let's do dry run with a smaller example. 4 2 0 3 2 5. Okay, we are starting the left and right pointer at the beginning and end of the array. Now we are taking left max equal to 0 and right max equal to 0. The left height is 4 and the right height is 5. Since 4 is less than 5, 4 will determine the level of water. Now we can process with the 4, updating the left max as 4. So for the first time, for the first element, what will be the water level? 4 is the minimum between left and right, and what is the height? 4 equal to 0. As you already know this one also, this is, suppose that this is 4 3 2 1, and for the first bar it will never going to store any water because all water will spill out. That's why the water unit will be 0 for now. Now we are moving the left pointer here. Now the left pointer is pointing to 2 and the right pointer is pointing to 5. The left max was 4. We will compare with this current pointer. So maximum between 2 and 4. What will be the left max? Left max will still 4. That's why I was saying it's safe to process with the minimum one. Step number 3, the left pointer will come to here because left maximum is less than the right maximum. The left max will not updated, 4, it will be still 4. Now again we will compare what is the maximum between the left max and the current pointer 0. What is the maximum? Still it is 4. Again we will move like this and we'll get the answer like for the first one we got 0, for the second one 4 5 minimum minus the height is how much? 2. 4 minus 2 is equal to 2. So first one is 0, second one is 2. Now the third process, it will be like 4 minus what is the height? 0 4. So the water unit will be 4 here. Again we'll move the pointer 3 4 and 5. What is the minimum? 4, because till now we didn't get any higher number for the left max. Now what will be the answer? 4 minus 3 equal to 1. Now we'll move to here 4 and 5. What is the minimum? 4. 4 minus what is the height? 2. And up to here we can move. Here we are going to break our loop. Now let's calculate 0 plus 2 plus 4 plus 1 plus 2. 4 4 8 1 9. 9 unit of water it is going to contain. Now let's move to the Java solution. Before moving to the Java solution, what are the points we have to do? We'll write here so that it will be easy to write the code. First of all, we have to declare the left pointer and right pointer. Left will start from 0, right will start from n minus 1. N is the size here. Now next point is we have to declare two maximum value, left max and right max, and both will declare with the 0 water. This is going to be our answer. And as usual, the two pointer loop we know, the loop will start as left less than the right. Inside this we are going to perform the operation. And here we have two cases. Case number 1 is what? Height of left is less than equal to height of right. When the value of the left pointer is less than the right pointer, what we have to do? First we have to update the max left. If it is greater than the before one, then we'll update the maximum left, and then we'll calculate the water. After a successful calculation, we are going to move our left pointer because the left height is less than the right height. Now the case number 2. What will be the case number 2? The left is not less than the right one. That means the height of right is less than height of left. If it is like this, then first of all we will update the right max if it is greater. After updating right max, again we have to calculate the water. Then we will do the right minus minus. In the end, we will return water. This is going to be our code. Let's write the code now. We are given with an array of height. Now we will declare the left and right pointer. Then left max and right max will declare as 0, and a answer, integer answer, or will take as water, integer water equal to 0. This is going to what we are written for this function. Now our first condition came for the 2 pointer while left is less than right. Inside this, our case number 1, if height of left is less than equal to height of right. First of all, we will check and update the left max. If height of left greater than equal to left max, then we will update the left max. Left max equal to height of left. Else, what we will do? We will calculate the water. Water equal to water plus the left max. Why we are not taking the minimum between the left and right? Because we have already written the condition. The left is smaller. That's why left max minus the height of left. Got it? Now the case 2 will declare with the else here. Means the right value is smaller than the left value. Then again here we will check whether the height of the new element is greater than the right max or not. Then we will update. Same as what we have done before. The height of right is greater than equal to right maximum. Then we will update the right maximum. Right maximum equal to height of right. Okay, we have updated the right maximum value. Now we will calculate the water level. Water equal to water plus right max minus height of the current element. Got it? And here also same thing. We don't have to find the minimum between the right max and left max because we have already declared this in the else. Else means the height of right is smaller than height of left. Okay, and here we will do, after this if else, we will do the right minus minus, and here also we have to do left plus plus. In the end we will return the water. Got it? Basically what we are doing here, we have an array. We are declaring the left and right and the left max and right max. We are moving the pointers whenever the pointers are smaller than the other pointer, and we are updating the maximum value, and we are calculating the water. That's all. And this solution will become big O of n only, and the space complexity also big O of 1. We didn't use any extra array. With this question, we have covered the core 2-pointer question to some reverse string, valid palindrome, move 0 and all whatever we have done till now. But we are not done with this 2-pointer. We'll do some reinforcement problem. We are able to recognize the pattern without being told or not. And the question will be going to the square of a sorted array. So see you in the next session.